All right, so the next example that we're going to look at here is determining limits analytically. Now, I have a very simple example, and all we have to do is kind of just think about what's happening. And to be honest with you, sometimes this is even easier than just graphing it. But when we look at this example here, we're going to analyze the limit as x approaches 3 from the right of 2 over x minus 3 to the third power. Now, when I look at this, there are a couple things that I can notice. First, I'm approaching 3 from the right-hand side, so I know my values of 3 are a little bit larger. And the second is, when I look at my function, I can see that in the numerator, we have a value of 2 that's positive. So when I think about this, I know my numerator is always going to be a positive value. And my denominator is always going to be a positive value also. The last thing I look at is, well, let's just say I substituted in 3 directly into my function here. Well, I know I get 3 minus 3, which is 0. Therefore, I'm definitely going to have that undeterminate form. So I know that if I'm approaching this from either side, something's happening at x equals 3. It could be a vertical asymptote, and it can also be the other situation, which a lot of people fail to realize sometimes. It could be a hole. I will show you how to find out if it's a hole or not later on. But for us right now, when I look at this, I notice the numerator is positive, denominator is positive. So this is going to equal positive infinity because a positive divided by a positive is still a positive. Now, on the flip side, if we looked at this, let's say the limit as x approaches 3 from the left of 2 over the quantity x minus 3 cubed. Well, when you think about this, we still have a positive value in our numerator. However, in my denominator, I'm using values of x that are less than 3, or like, let's say 2.9. No matter which way you look at it, though, a negative number cubed is still negative. So this is going to equal negative infinity, because a positive divided by negative is negative infinity. Lastly, if I just look, or if I want to analyze the limit as x approaches 3 from both sides of the function, all I have to do is compare my outputs for the one-sided limits. Since the first output is infinity and the second output is negative infinity, they are not approaching the same value. This limit does not exist. The easiest way to kind of convince yourself, go into Desmos and graph it. Now, what I'm going to do here, since I used Desmos the first time, I know some of us have a TI-80 something calculator. So I'm going to go ahead and show you how to do this on your calculator. So here's my TI-84. There are a bunch of videos that kind of walk you through on how to do an emulator. If you really want to know, just email me and I'll help you out with that. But we're going to go ahead and just clear this. We'll go y equals 2 over parenthesis x minus 3 cubed. And then when we graph this, you can see something is happening at that x equals 3 line. We have, obviously, it's an asymptote. More importantly, though, when you approach 3 from the right-hand side, which is over here, it goes to positive infinity, which is what we expected. When we approach 3 from the left, on the left-hand side of 3, it goes to negative infinity, just like we expected. And since those two do not approach the same value of infinity, the limit as x approaches 3 simply does not exist. So I hope that helped you, and I'll see you in the next example.